Okay, audio check. 1, 2, 3. Sounds good, so I think we're ready to go. All right. Ladies and gentlemen, welcome to the Discourager of Hesitancy. We are building a game with no game engine. Today, we are going to begin replacing our crappy developer art with slightly better developer art. We'll classify it as mediocre. Basically, we built over the last couple of weeks our layout for our art. Like, this is where the pixels will go. And we put all that in the sandbox. So now the art we're going to develop going forward will conform exactly to those spacings, alignments, and projections. We're using an orthographic 45-degree angle for our camera projection. And I think that's mostly the news. So that's what we're going to work on. That will also enable us to start tidying up, fixing an actual layout alignment in the game itself, and doing transitions, scene transitions, all of that stuff. This is the polish phase. This is the phase where I usually say we're 90% of the way done. All that's remaining is the last 90%. Because that's kind of how software goes. Hitting the features and all of that, getting them all done, usually isn't that bad. It's all the polish and cleanup work you gotta do. So let's lay out our plan for the day. If I can get my hands on the right keys here. Week 16. Man, we've been at this a while, haven't we? So today's the 7th. Tasks. All right, 7th, 8th, 9th, and 10th. For now, we're gonna put those back into do. Ooh. Interesting. Oh, I see what I've done. Okay, what we're gonna do is we're gonna close out Emacs real quick. And we're gonna pop up a new Emacs. It's full of all the old compiler stuff we were looking at on Friday. All right, now we just size things for streaming. We open up our journal. I'm gonna put these back into do. Oops. Oops. All right, here we go. We did do notebooks and error banner last time, so we're good. Okay. Oh, we did that. Also, we not record that? Shame on us. What did we not record? Let's see, we did the journals and the notebooks. We did do the notebooks, so yeah. And the banners. So those were good. We did draw the bookshelf. Books. We got the UV thing when we went to rebuild the bookshelf. I did get UV size. To image warehouse. Yeah. Okay. So, oh, this is where we're at. Okay. Which brings us to today. Tasks. We're going to remove playmat, the play area material from GameScene. Put in wall color for clear and floor color as color quad for now. Okay, that's one thing we got to do. We can put in the chalkboard. Add new chalkboard. And table to GameScene. These have no functional change in anything. What else? We can add the notebooks. But now we're looking at a couple of different things we might look at. For example, a group, the table, and the notebooks. That is one thing we could do. We do have to make the left click, right click notebook operations. What else? Hey, JTL, good afternoon. How's it going? Select and copy. Yeah. How was your weekend, JTL? Relaxing weekend? Yeah. It was pretty good. My wife tried a new cheesecake analog recipe that we can have, so that was nice. I'm just counting down the days till October. October 31st. And how was your weekend? Similarly restful, I imagine. Hard to get much else done when you've got things scheduled in 2-hour blocks. A couple of chores here and there is about all you can manage. Um, I didn't get that far today. For the most part, made weight. Nice. Weekend off. Cinnamon rolls. Okay, good, good. Back on it today. All right, all right. Cool. Yeah, cinnamon rolls are good. Fun news is 2 dead vehicles, not salvageable. Oh dear. Yikes. I knew about your number one's vehicle, but the Suburban, that's news. Ouch. That's rough. Finding cars is no fun. I hate car shopping. I hate almost everything about cars except the fact that they get me from A to B. Maybe we start even simpler. Hmm. Just trying to think through what we got to do today here. Yeah, I've got to decide what to do about my truck. We've got the dead transmission, but I don't know if it's worth it to fix it because the motor is a little bit long in the tooth as well. So if I replace the transmission and then the motor goes, I'll be very sad. But if it gets another 10 or 20,000 miles on it, then it's cheaper than buying a new car. But I got to decide before winter hits. That's one of my better snow vehicles. It's got 4-wheel drive. Refactor. Okay. All right. So I think this refactor is a good item to start with. There's a number of places in the code in every scene actually where we have a margin, like basically a space where we don't want to butt up against the edge of the windows, and some spacings that seem to be common across all scenes. So we just pull those out, put those in the renderer, and then if we want to, we can change those later anywhere from a single point. That's a good Monday warm-up task. Um, I assume we left things in a more or less clean state. Yeah. Okay. So let's go do that. the other thing I was going to do, let's do another refactor in here. scaleW versus scaleH. We may move some other things in here as well later on. But for now, let's just get going light and easy. Okay. So here's the question. And I believe I already know the answer. If we take our frame width and we divide it by our reference screen width, so basically the largest screen width we can have, is this ratio any different than this ratio? And the answer better be no, because all of our width height ratios are 4:3, our aspect ratio. So we don't necessarily scale with respect to width or height anymore, since we are consistent. If we take any number, so basically the question is, if I take 1600 over 1920, that should be the same as 1200 over 1440. And they are. Imagine that. So that simplifies things a bit. Renderer scale. I think for margin I've been using everywhere. Let's see here. What's a good one? Not main. The about scene. Oh, interesting. Okay, well, Sandbox. I'm pretty sure that margin was 20. Big space, small space. Oh, interesting. Mm-hmm. Let's see your main menu. Big space was 20, small space was 10. Okay, anything else we care about here? This is going to break a ton of stuff, but it's fairly low effort, mindless refactoring. Okay. Let's just run a command, clean debug, and all the layout stuff is going to be broken. So that'll take us a few minutes to grind through. Get us back into the code and build cycles. Basically, all the scenes and a few of the components have some scaling that happens with respect to the screen. I'd like to move as many of these common measurements out as we can. So, for example, there's probably some pretty common font sizes. I don't want to deal with that right now, though, because we are going to fundamentally change all the buttons eventually. Maybe this week. We'll see. There's the first one. Easy to fix. Oh, there's the next one. Ooh, tooltip. Okay, so tooltip. Yeah, this won't take us long at all. Huh? Okay, easy. Some of these big button heights and big button widths are also sort of universal. So maybe we need to pull those out into the button class, maybe. Sandbox scene. Oh, yeah, this is all in the sandbox. Okay. This one's gonna have a whole bunch as well. Oh, not that bad. There. Ah, little Monday morning refactoring. Always gotta do the refactoring. People let it build up until it becomes a problem. Code is malleable. It's like clay. Not like brickwork, right? once you laid the brick and mortared it, it's not going anywhere. If you watch a good clay sculptor, they're constantly massaging and changing the shapes of things just a little bit to get the effects they want. Get that ideal perfect form. Okay, if that works, we're going to do a grep for big space, small space, margin. We might look at button sizes or font sizes. Okay. Cool, that works pretty good. Let's go on a quick restroom break. We'll be back in a jiffy. Okay. Interestingly, a jiffy is an actual unit of time measurement. If I remember right, it's 1/100th of a second. So almost never accurate in today's vernacular, but you know, that's the way we go. Okay, so that all compiled just fine. Margins and spacings. Static const double, or no, just const double. Margin. Exclude directory dependencies. Oh. Everybody uses a different margin. So maybe it's not as common as I thought. It will be common, but this is relative to playback. The top level labels are some amount off the top. These X's and Y's will be different based on the margins. So that moves the guesses, but the guesses will probably have to move anyways. So I'm not as worried about that. The bookcase is going to be changed. The letters will have to change because we're going to put in a new chalkboard anyways. So far, I don't see any reason not to change it. Everything else can change relative. Spacing. That's not very descriptive. Top labels. Playback stuff. We're going to relay out all the playback stuff anyways. The guesses. Those are actually going to be changed quite drastically here shortly. I'm not actually sure this spacing is very valuable to anybody. I mean, everything's going to get broken anyways, right? So big space. Like I said, everything's going to get relayed out anyway, so if we're changing things now, great. Small font size. Yeah, font sizes are another thing we might standardize on eventually. I don't think that needs to happen here. Okay. Okay. Scene. Text edit. Now this margin is not the same. This margin is the margin within the text edit. Which is not very big. So we can actually ignore that one. Okay. Tooltip. Again, this margin is different. It's not the margin within the window, so okay. I'm okay with leaving that. There's no like big space or anything in here. So big space does show up in a few places. 20, Sandbox, that should be fine. So yeah. These ones we can change. So about scene. GameScene we've already done. Explore scene. Menu. New high score scene. All right. We've already got those ones all done. Big space is now all relative to that. And margin should all be renderer except the actual components. So I think we're good. Last thing is to run it with a compile. Make sure it works. Okay, a little bit of refactoring. This is warm up. Now, I think we're just going to add proper clear color and the chalkboard to every scene. If we do this cleverly, we might be able to get a good effect going into the game. So far, I don't see anything terrible yet. Oops, sandbox scene. All that means is we forgot the semicolon there. Okay. All right, now every single scene we want this pale blue. Let's go take a look real quick. Source, let's see here. Source builds debug. Sandbox. So this pale blue, I actually don't really like it very much. We can make it, I want to reduce the red out of it somewhat. Let's find the right color here. Red, green, blue. So let's go to like 92. Like 216. If we were doing a more complicated game, like I would be all about building an editor so I could change colors, play with them real time. Yes, a little bit too bright. Something a little bit more pale. 128 to 24 or something. You're going to see this color in every single scene. A little bit more. 64, 48. Seems very green. Maybe we bring up the red just a bit. Could make this color part of the renderer, in which case, oh, that's very pale. Maybe a little too pale. 200 to 32. Oh, that's not bad. That's not bad. It's not distracting or hard on the eyes. Okay. I think that's what we're going to do then. Let's see. We can put it in scene. Everything else is in protected, so it's fine. Static const color, clear color. Oop, oop, oop. Okay, no. Every other scene does not have to set this at all. Sandbox. Settings. About. All right, we're going to CD source. Yep. Recursively for set clear color, excluding dependencies. Score scene. New high score scene. Back in the day, we had each scene with a different color, so we would know what scene we were looking at. And then as we've actually added content to each of the scenes, those all went away and became hard coded to black. So I think this will be a good start. Run it real quick. Oops. Yep, everything's pretty terrible. That's okay. This is covered by the playmat, so you can't see it anyways. Quick. Okay. That consistent wall color for all scenes. Oops. Refactored scaleW, scaleH to just scale, check the math, and this is fine because all supported aspect ratios are 4:3 are the same. Refactored margin, big space and small space into renderer. Actually, should those go into scene, not renderer? I don't think I want the renderer to know about margins and spacings. think we're gonna go do that. All right, renderer. It's okay if the renderer scales things. Is that true? Actually, that's a good question. I may not want any of this in renderer. I think scene makes more sense. Okay. After do destroy. Okay. Do you really want these to be static? Doesn't interact with anything else, so I'm fine with it being static. All right, everything's gonna be broken. The scene is kind of in charge of layout and what's being displayed where. Renderer just draws things, so let's keep the renderer clean. Ooh. Okay. looking forward, that will have to move into the layout or the layer. We don't support layers yet. Okay. Yep, there's the button. Oh dear. Button doesn't want to know about scene. Shh. Maybe scale has to go back to renderer. But not the others. So renderer keeps all the scale, since renderer knows frame sizes and such. That scene no longer needs this at all. All right. Slowly put the pieces back together here. Okay. Oof, okay. Okay. One last build should do it. Okay. Margin, big space, small space in the scene. That'll make sense. Anything else for now? Only base class. Scene sets clear color. So that now consistent for all scenes. Okay. Refactored clear color, margin, big space, small space, and what was the other thing? scaleW versus scaleH. Boom, done. Okay, for game scenes, we have about, game, high score, main menu, new high score, sandbox settings. Those are the ones that need a new chalkboard in there. Oh. We're gonna leave GameScene alone though for now. That is a special case. So about scene. We need a texture quad. Pretty sure all this is actually in there now. We can remove the comments, right? There's my full list of dependencies and fonts. Yep, so that comment goes away. Nice. A little bit of cleanup here. Picture quad and restore chalkboard. Do layout. Let's see here. Underscore chalkboard set. Texture. Image warehouse asset. Scene elements 1. Set UV. I don't know, chalkboard is scene elements 2. I'll apply UV. Word. Okay. Do layout. Constant double equals scene word. Center rectangle. Margin. Frame width minus margin times 2. Frame height minus margin times 2. All right, let's just, oops, probably have to do it clean. Change memory footprint of about. GCC doesn't play well with that. You relay out memory in the header file. We expect the chalkboard to be inside of a pale blue frame, but otherwise take up most of the window. If that works, we'll crank that same change into all the other scenes except for GameScene. Okay. So one question is, what is our question? So this font kind of wants to be more chalky. Right in here. Font store get font warehouse asset eraser. Text body 1. Text body 2. Title. Title. Okay. Ooh. I have to change the font sizes a bit. New layout. The fonts are for the buttons. We don't care about that right now. Oof, let's go to 35. Okay, so that fits. Okay, not bad. Good enough. Oh, GameScene we're skipping. High score scene. I have texture quad in here. High score scene reset. That's a new layout. Okay. Okay. Eject reset. Margin. Okay, so that should take care of that one. Drew Vest, good afternoon. So far, I'm doing pretty good. We're doing some like combination of refactor and starting to put the new mediocre art assets in where they belong. So the first thing is every scene is going to have that pale blue wall color and a big chalkboard. Everything's going to be on top of chalkboards. Then when we go to the game scene, the chalkboard will just be off to the one side. So we're updating all the game scenes to have their chalkboard and the right colors. So that should be high scores. Let's go to the main menu. I think I want to do this one. So we go to the about scene. In this include picture climb chalkboard. Okay. All right. Sounds nice. Yeah, had a pretty relaxing weekend. Um, Nothing too new to report. So we were gonna go camping Friday night, Saturday morning with the kids, and we got all packed up, big piles of stuff in the garage, ready to move out to the car. All the meal was prepped, and a giant windstorm came out of nowhere, 45-mile-an-hour gusts. So, and we've already been very dry this year. Lots of fires near here. So you can't really cook with charcoal or campfires if it's gusting 45 miles an hour. Let's see, what is that? 45 mph in kph, kilometers per hour. 72 kilometers per hour winds. So we canceled that. I still cooked the meat, but did it over the stovetop instead. It was very sad. And we're getting late enough in the year that I really don't want to try camping again. So my kids are a little bit sad, but okay, that's the way it goes. And how was your weekend, Dravest? All right, so let's see how this looks. Okay, yeah, so there's a pale blue border everywhere, a chalkboard, and about has the same chalkboard, and high scores has the chalkboard. We're going to relay out high scores menu a little bit, but the idea is here. Okay, so let's see, maybe settings and the new high score. Okay, we don't have a picture quad here either, so not seeing. Let's get a texture quad. Put in a chalkboard. Okay. there's settings scene. As long as that builds, that should be fine. This is going to make our transition into and out of the game itself much more complicated, but I think it'll be a nice touch. When we get it all put together. Scene to scene transitions is not a thing we've spent a lot of time with. Like we've kind of barely touched on it in a couple of places. Like if I remember right, the about scene, things fall in, shift left and right while you're using the buttons, and then they fall off when you're done. It's not the worst plan to use in a general sense, but we do want the transitions to feel nice and smooth where we can. The next one is new high score scene. So just going to add it in. Here's the big space. Unfortunately, right now, the only way to get to the new high score is to cheat, so we may have to cheat our way there. Which, maybe we do a little bit of, tiny bit of coding in GameScene to make that cheating better. Part of me thinks it's a good idea. Another thing we might want to do is well, I don't really want to do it. Is that true? So one thing that would be nice for testing purposes is if we could fill the bookcase with guesses automatically, just for efficiency. So see, we said high scores needs to be relayed out about. We did relay out settings. A little bit of relay out, not much. We can move things up a bit. Otherwise, that actually still looks pretty good. We move things up a scotch, and that lets us move the back button up a bit. These labels all need to be chalky. So we can come back to that notion. High scores, about settings. All right, so settings, let's go to the labels. Change the font. do all the labels. Oh, right here. Perfect. Set font store get font warehouse asset eraser. Oops. There. Done. The font sizes for those will be wrong, I'm sure. So Y starts there. I think we can move that to 100. Nothing will suffer for it. Maybe. Settings. Oh, actually, those font sizes aren't too bad. So we missed screen size and this thing somehow. It's these two. And where did this one get a color from? Down here and the alignment? Where did this one get its? Stuff. Okay. Put it all in the same place. Backslash. Okay. Okay. So I think it'll be the settings scene. Just about done. Oh, this one didn't get pulled up at the same time as this one did. 100 pixels in looks okay. Oh, but that didn't render correctly at all. Why not? This eraser not have a send symbol? What? Oh, I hope it does. Glyphs. Plus, minus. Huh. Well. Well then, what am I supposed to do about this? I suppose I can put like a multiply in there instead of a less than. Plus, minus, comma, dot, forward slash. Where's the multiply? No multiply either. Oof. I guess we use a hyphen. Really, he gave us a hyphen, an N dash, and an M dash. Actually, several dashes. Yikes. I guess we use a dash. Oh. Oof, okay. We may have to replace that from a text to a texture quad anyways, eventually. Which that would make me sad. Okay, settings. There we go. Yeah, not the worst. I mean, an idea I have is to make this a combo box, like a drop-down menu. But that adds a lot of complications. So you see. All right. Oh, yeah, that font does not have a lot of glyphs I might want to use. I will have to carefully check everywhere we use that eventually. Okay, so everything's moved up. Let's move that back button up. Is the frame height minus the button height plus a big space. This might just be the new thing here. Okay, there it is. That's okay. All right. I'm going to call this one done for now. So that was settings about. We're going to move these buttons up. Did I have a label here? I don't remember now. So about. Text page. Oh. Yeah, it's the page number. So on measure the chalkboard first. Text page. Okay, what are we doing here? That takes us back. Okay, good. I'm not sure what happened to the label for our page number. Yeah, where did that go? Where is it? Where is it? We've got a font, we've got a text color, and an alignment. We are rendering it after the chalkboard, so it shouldn't be hidden. We're setting the rectangle, looks like in the right place. If we're using animations, we snap it up. There it is. Okay. All right, we're back in business. So that was okay. High scores. High scores is a little bit of a problem. So I was going to move this stuff down just the scopes. That's fine, but these buttons are just too big to fit here. These buttons need to move up. But what do I do with these buttons? Do I make them smaller? Do I put them underneath here? Let's go play with some numbers here. Let's move high scores, marathon, etc. down. High scores scene. Mode switching buttons. Yeah, let's come back to that. Reset. Okay, blah, blah, blah. Titles. big space. Oh, okay. Pixels. That was that down. Back button. Yeah, 100 pixels up. But in general, I don't know what I want to do about the mode switch buttons. Mostly good. Oof. Yeah. Okay, well, option one, could put like the left right button here next to marathon. Like just the left right button. That could work. Let's change these fonts. Okay, settings, back, about, back, high scores. Oh. Not bad, not bad. This whole table we've drawn needs to become chalky. I'm kind of leaning towards left and right buttons. This can be smaller. Boom. Make it left and a right button. What I want to do. I think I have to. Those three. This isn't even the hard scene yet. Does this one have a transition into? Everything falls in, so these will have to fall in at the same time as that. All right, gotta change it. Gotta change it. Button next mode, previous mode. Button marathon. So that is now button next and previous. Ooh. This actually gets a little bit more complicated. Not too bad. Functions to make this easier. Void next mode previous mode. Piece by piece. All right, we can do this a couple different ways. We can do it with like a switch statement. We could do it with a let's see, switch, or we could do it with integer math. M underscore mode. Let's just do it with a switch statement real quick. M underscore mode. Play mode. Marathon. Play mode. Sprint. Play mode. Golf. Okay, marathon to sprint, sprint to golf, and golf to marathon. And vice versa. Marathon to golf, sprint to marathon, golf to sprint. Okay. Okay, mode switching buttons. This is not where they go anymore. We'll come back to this. Let's see if this is big enough text. Request reset. Okay. All right. I just have to place those buttons. All right. Uh, so these are basically at the same place as the mode text titles. Mode subtitle. Right there. Mode subtitle. Set font. Set rectangle. Right there. This one. Okay. So the subtitles at X and Y. We can start there. Plus, yeah, so we're giving this thing the whole frame width, which is a little bit silly, but that's fine. We'll just work with it. Render scale. Some amount. I don't know. Let's just go somewhere and somewhere. I don't suppose it really matters that much. Just to get things on the board. Okay. Reaching value practice is not handled. Good point. It should never happen. But we can show marathon in both cases. Okay. Might be better to calculate the 1/3 line and put the buttons at the 1/3 lines. Not the worst idea. But we just want to throw it up on the screen, make sure that the functionality works. Trying to establish more of a style. I hope it works. I don't remember what animation we had for those 3 mode switching buttons. Shockingly, that all compiles. Okay. Well, okay. Okay. We don't do that at all. We need to put these two here. So title gets laid out, and then it throws the height on. Then this one adds its height, and then this one adds its height. So that's why they were running so low. 4 and 8. Let's take let's double screen third equals screen width divided by plus a screen third plus 2 times a screen third minus small button width divided by 2. See what that looks like. Okay. That is much, much closer. So this is the screen third, and this is the screen third. This doesn't look very centered then. But those buttons are also much larger than they need to be. So the small button width navigation button width, which is 75. Okay, let's try that. As long as the word marathon fits in between them, reasonably centered, we may just call that good. Oh, not bad. These are backwards. Marathon, golf, sprint, marathon, sprint, golf. Okay. Here we go. Okay. Nice. Okay. So I would say looks about done. Settings looks about done. About, we already looked at. Okay. So that is the major relayout for all the scenes except for the game scene. Let's see. So this one has no animations. About does. Kind of want this one to fly up from below. This number. High scores animates in and out. Oh, just in. Oh, interesting. Animations. Scene transitions are a thing we're going to spend a good amount of, not a good amount of time on. We're going to spend some time on. So about's done mostly. And high scores is half done. We didn't animate out or out for high scores, huh? Settings has animations. Okay. Overall, I think we're getting much more consistent style going here. Okay. Okay, so the chalkboard. All scenes except main scene have chalkboard. Now, change text to eraser and hid other layout. Clean up as needed. Scene transitions. About scene. Should lie up on enter. High score scene is animation on enter, but not on exit. Main scene has none. Main scene and settings scene. Okay. All right, so let's see where we're at here. Git status, git add, everything. Making consistent style in all scenes except game scene with chalkboard and attendant minor updates. Okay. Not bad, not bad. Let's see here. I think we'll go on a quick restroom break. And we'll start tearing into that main menu, not the main menu, the game scene. That one's going to take a good amount of work to get laid out with new stuff. Be right back. Okay. Now, GameScene. This changes a lot of the GameScene animations just by doing this. So we need to think a little bit. But we can just get started. So let's see. GameScene. Okay, the play area material is going away. Okay, so that no longer exists, and we should no longer see that resource. Okay. There we go. There. See? Perfect. Now, what we need is a chalkboard. Bookcase and the table. Um, marathon real quick. Eat. I'm going to fill it up. So interesting word. Oh, actually, well, that is a little odd, actually. Hmm. Okay. Okay. So here, so here we see so this one needs a little bit of layout work still. How hard do we want to try fixing this? Removing the done button up. This needs to be eraser. So let's go to new explore scene. Button done. Renderer scale 100. That's one thing. Congrats. If we go to application, and load straight into the Explorer. See if that works. On startup, it may be asking more questions than we want. It may crash. Oh. Okay. Not bad. Okay. Times 3 plus the big space. Also, our big label width. Okay, let's try that. How was my weekend? Yeah, pretty good. We did not go camping. There was a big windstorm, so unsafe to. Oh, interesting. So we didn't do that, but otherwise it was pretty relaxing. Tried a new fajita recipe. It was pretty good. I cranked up the cayenne pepper a bit, so it was nice and spicy. Just the way it should be. Okay. Hmm. Big label width. Oh. Why are we looking at the small label width? Issue. Right. Here we go. Yeah. Yep. Well, I've tried a new recipe for a cheesecake recipe that works with the diet currently. So that was nice. A little cheesecake. There we go. Enter your illustrious name to preserve this achievement for your posterity. Okay. Oh, that one needs to be updated. Ah, okay. Yeah. How was yours? Are you still packing up boxes, getting ready? Why is that cursor not scaling? We had scaling working with all of this. Dadgum. Okay. Shoot. All right. We have a bug. Bug. Text edit. Cursor not scaling correctly. See new high score scene. Okay, that's unfortunate. We're not gonna fix that now, but shoot. Okay. Okay. So we took the play material out. We put in the wall color. That's fine. The floor has a color quad. Let's get back into what we were actually working on here. If we go to Sandbox. Lower. I do a color quad. Great. Offset. Okay, ultimately, margin, shelf extrude height. Let's grab that. And the shelf height, shelf extrude. Shelf extrude height. We'll eventually need all of these. Okay. Floor goes on the back plane. All right. Okay. So yeah, we have our crappy game art, which we're partially taken out. We're putting in the mediocre game art, which at least is laid out pixel correct for us to tune our layout and our animations. So that's where we are. Is slowly putting back, well, not slowly. We're putting back in the new art where the old art used to be. And by old art, I mean like crappy rectangles of solid colors. Whereas now we at least have a consistent 45-degree orthogonal projection. But they are the pixels that will actually be used. So we can use those as printouts to then do the main art over the top of. Oh yeah, this is like that. We're in the polishing phase, so we're not really building new features per se. Okay, so there's the ground plane. One question. This loading in animation kind of needs to happen in two stages. The current stage that we see where everything falls on to the scene is actually the next level operation, right? So if we go, whatever. Let's go to golf mode. If we cheat, everything flies up and then flies down. So all we're really doing is taking the second half of that animation as our entry animation, but that's not the way it's going to be from now on. That will be a second of two phases. One phase will be, we go from this chalkboard and it's going to zoom to its new location, and the floor will rise and the bookcase will fly in somehow. Then all the rest of that animation will happen. Okay, so we're going to bring in the main game elements in one phase and then drop in the more interactable details in the second phase. So I guess we need to get that chalkboard in there. So we've got the floor in. Even if it's not animating. Add chalkboard. We need to add the chalkboard and table. It doesn't cost us anything to add the table. Okay. GameScene has floor now. No, oh, actually, let's remove the playmat while we're at it. In our assets, images, playmat goes away. I kind of want to get rid of the sprites testing. And, well, we'll come back and do that later. Let's just throw in the chalkboard. Ooh. Okay. Did some layout cleanup of new high score scene to match the others while we were there. Tidy up on aisle, new high score scene, main menu has a floor plane. Oh. Assets, images, playmat, PNG, and .x. Yeah, we can always get this back if we want. As a new floor, remove the old playmat. Play area material. Okay, there we go. Boom. Now, we add the chalkboard and the table. We have a whole bunch of constants already defined around the chalkboard, so in Sandbox, view layout. Let's see here, not that one. Chalkboard. So the floor let's see. Sandboxing. We need the underscore chalkboard. The chalkboard is drawn on top of the floor. We might as well grab a table while we're at it. So we'll have the floor, the chalkboard, and the table. Init game elements. Replay stuff for some reason is near the top. You actually want the floor partially set up here. So I'm just going to floor set color. There we are. This chalkboard is actually going to be very similar to that. Underscore table texture UV can be set here. Chalkboard. New layout. Start the floor, chalkboard on top of that. Okay. Table. Shelf X, shelf Y, shelf extrude. Chalkboard wide plus width plus margin plus table width plus table height. Okay. Looks okay to me. Then on render. And we'll just go to chalkboard. Oops. And the table. This is all our new pixel perfect art being drawn. Yeah, that game loading sequence might be get a little more complicated. That's okay. The bookshelf's gonna be the biggest pain in the neck, I think. Yeah, maybe not. Maybe it's not too bad. Uh-oh, there's an actual error. Shelf X was not declared. Basically, everything is laid out relative to the shelf. Oh. Okay. Still has an error. Oh. Maybe these come after that. Invert offset was not prepared yet. Fun times. Vertical offset. It's just a number, that's all that matters. Okay, there is our chalkboard and our table. Perfect. Oh, nice, we did it. Hooray. Okay. So let's clean up this layout according to the new stuff. I think letters on top of table makes sense. I'll break these out into more functions, but like they're all relative to each other, so I don't think we're gonna top labels, guesses, we'll come back to those. Letters on the chalkboard. And these deduced letters. Or chalkboard. Oops. Table. Okay. So our chalkboard. Ooh, pardon me. Man. Okay, so we got chalkboard X, we got chalkboard Y. I think this stuff happens elsewhere. Oh, letter font size. Where are the underscore letter text? Let's reset the text. Set font. Set text color. Set alignment center center. Okay. So alignment, font. Set center, and then we can set the rectangle. We are not messing with the colors here because we don't, yeah, we can actually look at real colors. And then how we advance depending on what row and column we're in. Okay. Color. Okay. It isn't. It's M underscore reduced letters. Okay. Okay. I think that should lay out those in the same way. Well, let's see here. Do the layout. Chalkboard alphabet. Chalkboard solution. Reduced letters. Shouldn't have to any cleaning or debugging on that. Cleaning. Hmm. Well, also don't have the proper treatment. Okay, okay. Okay. Now we're cooking. Okay, so this is our final letter positions of everything. These buttons. I think need an X and a Y offset. Those were offsets that we were screwing around with before, just based on other things, but we never came back and cleaned up that. So, I still don't like that either. We can move the X over, but what happened to the Y? Hmm. Okay. Just feels like those should be just a little bit more down. R2, letters 13. Oh, except Cosmos is moving it up half the letter height, not the right answer. Hmm. You're literally getting the rectangle from one of the letters. 13. It's probably like H or something. The top of the button should align with basically this. Oh, wait a second. No. Hmm. Confused about why that doesn't line up the way I think it should. Something in the math isn't working out here. The buttons are all going to be redone anyway, so maybe it's not the worst thing in the world. Hmm. Hmm. You want to throw the banner in? I kind of want my bookshelf. Okay. Chalkboard buttons. Let's just put those right here for deduction spaces. The banner comes in after the current guess. Not sure how I feel about all that. Okay, so the guesses. Make sure the guesses are coming up. Basically, we're through table. This is kind of where we're working at. Is the bookshelf complicated enough that I want to separate it into its own class? GameScene is 2400's lines of code. What it takes to make the bookshelf tick is enough of a pain in the neck that I kind of think I do want to separate it. And the books. But is that even true? Is that true? Yeah, I kind of think I do. Is that true? We can add the notebooks real quick while we're thinking about it. Lower chalkboard table. Notebooks. Static const int notebook equals 4. Set texture UV key. Init game elements. Or chalkboard table. See notebook count. Oops. Okay. Oh yeah. Let's do a full clean from time to time. It might be nice to hide away a lot of the bookshelf stuff. I have a loose ends list item that I don't know if I've written down, but fine. Needs a way to work with both local coordinates, so like if you have a parent-child relationship and you're inheriting the transform from your parent, as opposed to the local, which is just your current XY offset relative to the parent. So we may have to revisit. We may have to visit that one. Okay. So there's the new notebooks. They don't do anything yet. But they are rendering. And now it's on the table. Rendering them. Animate. Dropping. Rising. One of the tricky bits might be indicate which is active. Somehow. I think I need two book textures. One for open, one for closed. Open book, closed book. Okay. Actually, clicking those books is a little bit of an interesting problem in itself. Which I'll have to think about. It's part of the problem. These are technically rectangles. Rectangle, 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 rectangle. So when I click it, how do I detect if it's been clicked? Like, do I want to check for the front cover? That's easiest. That's two triangles. We know how to do a triangle test. Or to do corner to corner and call that a triangle, but then like this pixel here wouldn't be in the triangle necessarily. And this triangle, again, clip some of that off. Or we can go with two rectangles, or two triangles, and two triangles to get all three sides. That would give you the tightest click detection, and this space here would be the only exception, which nobody would care about if you clicked or unclicked it. So So yeah, books are going to be a little bit of a fun problem. Which we'll have to think about. Okay. Okay. So we're going to ignore notebooks for now. We're going to start on bookcase. And I think we're going to make it a separate class. Quite a bit further than I thought we might today already. So we've got source, a bookshelf. Okay, we need texture quads. And we can't just do a batch texture quad. Everything has to be drawn in specific orders. What else do we need? We probably need renderer for scaling. Sandbox. We need all of these. Need these. We need we need so many things. We need a render. Init elements do layout. Okay. Bookshelf. Init our elements and then do a layout. Sure. Ugh. This whole layout thing is going to get to be a big pain in my neck. Because of that unfortunate design around the affine parent-child relationship, relative position information. Yuck, okay, all right. Bottom left, center. Okay. All these constants don't mean a thing, unfortunately. Render. That is the order to render things in. The main issue is here in do layout. So what am I going to do with that? XY width, height, extrude. All the shelf numbers, those all make sense. The XY I don't like. Everything here should be relative to 0. The other thing that needs to happen in elements. Set parent. Or let's see here. Static constant shelf count equals 18. Book set count 10. Okay. Time for bed soon, Javest. Yes, I will be on tomorrow. You get some good sleep. Thanks for dropping in. Okay. So this should set up the correct parent-child relationship for everybody. Everything should render in the right order. All of these should be initialized with, image warehouse. We should probably get that in here. Okay. And then we have a whole bunch of constants, some of which we do care about. Let me think about this for a second. What's happening in Sandbox scene in our layout test. We have all these constants. These ones, I think I can just copy. Straight into here. Yeah, shelf X and shelf Y will always be 0 in our case. Width, height. Okay. So that takes care of those. Bookshelf. There's a set rectangle. Is it protected? Have the local transform and the world transform. And a fine does not have an actual rectangle. Who's calling set rect? Huh. Set a fine rect. Okay, we can do that. Shelf width, shelf height. Okay, so we need our bookshelf. Everything is laid out relative to this. Oops. Okay, everything's laid out relative to 0, 0. So that should be fine. And on render, it shows everything the way it should, which means if we go to GameScene, bookshelf.header, bookshelf, bookshelf. New layout. and notebooks. Okay. Bookshelf. Move to shelf X, shelf Y. On render. All right. Oops, that's not gonna work. Oh, because I didn't add the bookshelf to my make file, so it's not gonna build the object file. So when it tries to link it, it won't find the definition for any of the functions of the bookshelf. Fun times. Oh goodness, 3:30. It's almost snack time. Hey man, Diaco Curdo, what happened to the game and compiler? So, working on the game today. Compiler is Fridays. Game is Monday through Thursdays. I want to ask you about the graphic library you're using for the game. I am using OpenGL and nothing else. Oh. Need to make this. Then we need that bookshelf to it somewhere. I guess the other thing we're using for graphics, technically we are using GL Math for our transforms. It's overkill. In our next game, I want to remove it. And then for font rendering, we're using free text, free text 2. Free type 2. That's it. This is my full list of dependencies. Glue, GLFW, OpenGL, GLM, free type, and port audio for sound. You want to learn C now just because of GTK? Okay. Well, I've always said people who take programming seriously, like if you want to be a good programmer, learning C is one of the first steps, because C is, I think, about the right level of abstraction to force you to understand what the machine is doing without having to write actual assembly code. Now, I think everyone should also write actual assembly code, but that's a hard ask. If you know C, you understand where your memory's at, where it's going, where it's coming from, how to keep track of it. It's a little bit of a cognitive shift from a lot of higher level languages. C is a low level language. You have to keep track of everything yourself. But you can do anything with C that you can do with any other language. I can't comprehend pointers in both C and C++. Like, what is the point of pointer? I don't know the syntax. I just don't know in what situation to use it. Yes, that is an excellent question. Let me finish up this change here and at least make sure that it... I want to see what happens, and then we'll take a look at it, okay? I have no problems talking about pointers. Bookshelf.o. Let me just get this into... Oops. Movie bookshelf. Where's my game scene? Sure, we can put it there. Game scene. Now I'll try this. Yeah, we'll talk pointers here. No, it's fine. A curious mind is good. And sometimes it's good for me to break up the monotony of me droning on stream of consciousness while I program. So if you want to talk about a topic, we will talk about a topic. Pointers. So I guess for context, what languages are you more familiar with? Just so I can draw analogs that might make sense to you. Okay, you are familiar with C++. C++ does offer a lot of tools for managing pointers that C does not. I tend not to like them, but that's my own personal hang-up. If I teach you enough about the C pointers, I can then teach you enough about the C++ pointers to understand what they're doing. Oh. Okay, so that's all fine. Bookshelf needs a color quad. Let's give it a color quad. Let me just finish getting this to build and see if we can get to show up. And then we'll go talk pointers. Okay. Okay. Oh, I do need to pass that. Okay. I actually do. Okay, let me just go grab that then. That for constant reference to, what are we calling it? View projection matrix. That should be what I need. Oh, come on. Underscore view 1, 3, 2, 3. Okay. If I could remember to put in some. Texture quad shelf equals shelf sub index plus index. Okay. I think we might actually build. Will we run? Okay, we run. Does the bookshelf show up? It does. There is a bookshelf. And nothing lines up, and that's to be expected. We're fine with that. Cool. Okay. That's great. Okay, time for pointers discussion. Pointers. Where to begin? Let's save this work we just did. Journal. Add bookshelf to GameScene. We've got that done. Render it. Okay. First step of bookshelf added to GameScene. It lays out okay. Have not tested the books. Okay. Initial bookshelf in place and visible. Okay. Pointers. A computer program is a series of ones and zeros in memory. And I can give you several different lying ways of thinking about your memory. For the purposes of this discussion, we're going to ignore a whole bunch of stuff and tell you a lie that's useful enough. Okay? We're going to lie. We're going to lie, but it's a useful mental model. Okay? Let's pretend that our program is something like this. Let's say int x, y, z, int red, green, blue. Okay? What this tells the computer is I want in memory 4 bytes for x, 4 bytes for y, 4 bytes for z, 4 bytes for r, 4 for g, 4 for b. So what you could see is something like this, where it's 1, 2, 3, 4, 5, 6, 7, 8. Let me just give you a couple of different small pictures just to get you oriented. 2, 3, 4, 5, 6. Your memory actually continues, right? So here at address 0 is x. Here's the variable y. Here's the variable z. Here's the variable r, red, green, and blue. These are their locations. And this one is at location 0 in memory. Okay, so that's an address where that data is stored. Y is at address 4, meaning 4 bytes offset from that first one. Z is offset 8, because the size of an integer in some cases is 4 bytes. It's fairly common these days on a modern architecture. G would be 16, and B would be 20. Okay? So that's one way to think about it, is as your memory, your RAM, is an array of data, and you can partition it up and say X is these 4 bytes at this address. Okay? So if you want to say Z plus some number, what the computer actually does is go to memory at this address and then change the value there. Okay? Yep, good. Track it. Great. But there's actually 2 sections of memory. What often happens is you have a heap and you have a stack. Okay? And what we're going to pretend, and this is a lie these days, don't think this is how it actually works, is that memory on the stack is going to grow up, and memory on that heap is going to grow down. So these variables that I declared, x, y, z, RGB, they're on the stack. So what it might look like is x is here, y, z, RGB, and it's growing up. Okay? What happens on the heap is if I say I want, we want something, let's say we want a pointer to, oh gosh, I don't know, a vector. Oh no, it's not int. Let's do a vector 2. Oh, let's just do an integer. Integer pointer to a value equals some new integer. Okay. What that does is it says in the stack, create a variable called v. And this, so let's give these addresses, right? 0, 4, 8, 12, 16. These are on the stack in the same way we were looking at it before. And v is going to be at 24, and it's going to be 8 bytes long because we're in a 64-bit architecture, right? And what v points to, what v contains is a pointer. We'll say 64-bit pointer. To another address. So on the heap, when I said new, what this does is it says to the compiler, it says, at this time when we're running, ask for a new piece of data. So this will go here and we'll say, I have this address here at 100. You can have that. And we can set it to a value, right? So the contents of v equals 13. 13. Okay. So when we said new int, it said, give me an address where you've stored enough memory for this integer. And then the contents of that address. So when we said v, the contents of it, it says, I know this is a pointer, but I want you to actually do something with what we're pointing at. So v points at that address, 100, okay? This assignment says, take the address that we just requested, especially saved aside for us to use, and now give me the contents of that address and set it to 13, okay? So that's one reason you might have a pointer, is that you have memory on the heap. To get memory on the heap, you have to use the new or malloc keywords, right? For no, that's fine. So I can now do things like, well, one, I can delete v, right? Or free if you're in C. And now what that says is this address, v24, whatever it's pointing to, give it back. So now this v is still pointing to 100, but that address is no longer actually available for v to use. So that's when you get things like seg faults. You're pointing at memory that you've already freed. Or, here's another fun one. If you just have this, what is v? I don't know. It's a random number. It's a value. The compiler didn't give you an address at this point. So you don't have an address. So if you try to set the contents of v to 13, v is not pointing at anything on the heap or the stack either, right? It just doesn't exist. It's pointing at garbage memory. So that can often cause you to fail in many creative and interesting ways. Which is why you always, well, you can do null pointer, and what that does is it says point to nothing, right? We didn't allocate memory on the heap, and I want you to point at nothing. Now if I try to dereference it, that should cause the compiler to hate me. Well, not the compiler, the runtime. Okay? So, that is a couple of different things that can happen there. Another thing that might happen is you might have get darker version of a color given darkened. Let's do int r, int green, int blue, right? So we have a color, we just want to get a darker shade of it, that color, right? Well, how do I get those three values out? What if I could pass in pointers? Because what happens here is you actually open a new activation frame, right? So on the stack, you get a new activation frame. What this means is inside this scope, we basically have a new chunk of memory that's set aside for it. And on top of that, we just declared a new R, G, and B, right? So we have R here at 12, 24, 28, G at 32, and a new B at 36, right? 36. So when we go into this function, it said start this function. And now here are 3 new places to store stuff. Well, I have no way to get 3 values out. I can only return 1. Even if I said int, right? It won't work. So one thing I can do is I can pass in a pointer to red, green, and blue and say, look, here's some memory. I'm going to point to a location. Do your math there. So I can say like R minus equals 10. Except I can't do that because it has to be the contents of R. Because R itself is a pointer. I want the contents that R is pointing to. Contents of G minus equals 10. Contents of blue minus equals 10. This is not actually, by the way, how you do darkening. But it's just an example. Now, there's nothing to return. I can call darken with my own RGB, but I have to give them the address, right? So what that does is it says this address here, whatever these are, which in our case is 12, 16, and 20, those are the addresses we pass in for this thing to manipulate. So it says the contents of memory at address 12, decrease it. The memory at address 16, decrease it. Memory at address 20, decrease it. And now I don't have to return anything. Those values have all been updated in place. So although these values are on the stack, I can still manipulate them with pointers. Modern computers have enough RAM. Why be so cheap about RAM? Do modern computers have enough RAM? That is a good question because I keep trying to load web pages, or I tried to turn on a TV the other day and I had to wait. I can't believe something so simple as displaying a little bit of static text and an image takes so long, because people don't think about how those resources are being used. We've added so many layers of abstraction that a programmer, unless they really care, has no idea what's happening in memory. Yeah, so let me give you per Pat's recommendation. There's another version of darken. Let's call it void darken with reference. We can do this like this. And this is where the syntax of C++ really starts to get annoying. These are references, and all they really do is hide that what you're doing is passing pointers. It's the same thing. But instead of calling dereference, you're literally doing the same thing, right? So we can pass by reference in 2 ways. In C, all you can do is with pointers and addresses and dereferencing locations. In C++, this just hides what it's doing. This is what it's doing. This is what it compiles to. But these are just references, which means it's a pointer that you don't have to treat like a pointer. One reason I don't like this is because I've seen it before where somebody changed one of the parameters being passed, and everything changed how it worked because you weren't working in the same memory that you thought you were working in. Like the figuring out what memory you're working in is actually a huge part of the difference between C and C++, right? C++ tries to hide what's happening in memory. Like, actually, that's one of the reasons I hate Java. Everything is a pointer. They just don't tell you that. When you ask for an object instance, you're getting a pointer to it, and they hide all of the dereferencing and who it is and where it is and whether it was copied or not. Is there a performance advantage to pointers? Depends. Sometimes. if your data structure is trivially copyable, it can often be faster to just pass by value. Hey, yeah, have fun cooking for the doggo. I'm assuming the doggo doesn't eat quite as well as you do. But a pointer is a fast copy because it's just 64-byte value, right? It's a 64-bit integer. So you can get a pointer thing without doing any copying. So a lot of the times, if I'm passing a large data structure like void, oh gosh, add extruded walls to, or let's see here, get bounding volume, right? I'm going to return a cuboid. Get a bounding volume. Maybe I'm passing something very complex. I can do something like const building pointer building, BLDG, right? Now I'm not copying building, which can be a whole mesh, right? So vertices, tri-indices, materials, etc., etc. I can just pass in the constant pointer, and it's a 64-byte copy onto the stack. And I have access to all of the data that was already existing in the building object, right? So that can be much faster than trying to do this. This will try to do a full deep copy of everything in that building. Or, depending on how it's implemented, and this is the problem, you don't know how it's implemented. When I pass a building, what does it actually copy and what does it share references with? That's another danger. So yeah, all a pointer is an address in memory. That's all it is. You have to just be careful about whether you're talking about the pointer itself or the value the pointer is talking to. And as in any language, no matter how hard they try to hide it, they're all using pointers, and you have to understand when memory is allocated and when it is released so that you don't break it. Yeah, so Java, it'll be like, oh, that's a null value. You're like, what? And then you look at it, you're like, oh, of course, I didn't set it to something, so that didn't allocate memory there. It's just a pointer that's pointing at nothing. No reference exceptions. Yeah, and in Java, I can't even choose when it's being released. Everything there is reference counted. So, reference counting is the same thing as a reference counting. It's called a shared pointer in C++, right? And what it is, it's a data structure which says what I have, let's see here, shared pointer of some type. And we're just going to say integer, it doesn't matter. What we have is we have an integer pointer to some value. We have an integer reference count. Okay? So look, here's a pointer. Every time we assign that shared pointer to something, equals the address of some x, it doesn't matter, some x value. When we do this, x pointer now points to the address of x value, and this thing got bigger. So it's now 1. When we say y pointer equals x pointer, this now becomes 2. If we're, as we fall out of scope, x pointer and y pointer destruct and go to the shared pointer and say, hey, I'm not using you anymore. And the other one says, hey, I'm not using you anymore. And as soon as it hits 0, it says, oh, this value, we can delete it now. So that it sort of auto cleans up after itself. Now, that all sounds lovely and wonderful until you're inside of a very tight game loop and it's reference counting. It's going up and down, plus, minus, plus, minus, plus, minus. and then it hits 0, and that memory goes away, and maybe all that overhead is killing your frame rate. Because it's a lot of counting and checking and branch predictions. So, and this is how Java works, right? It makes everything a pointer. You don't have any control over that. And you have no control of when it's freed. When this reference count goes to 0, that even doesn't free it. It marks it as unused. And then that goes into the garbage collector. And the garbage collector waits until who knows when. And then it fires off and says, oh, let's gather all the things that have been marked as deleted and actually delete that memory. So you can be running a program and run out of memory, even though there's a whole bunch of stuff that's not being referenced anymore, right? Maybe the garbage collector didn't run before you ran out of memory. Or maybe you're, in a first-person shooter, you're running along, running and gunning, and you go to shoot the other guy, headshot, a 180 no-looker, and you spin and your frame rate stutters. Why? Because the garbage collector is trying to clean up garbage at the worst possible time. You have no control over when it fires. So that's one of the reasons that a lot of high-performance computing avoids such high-level languages. You got way more control. Now you have to keep track of more, but I would argue that you still have to keep track of all that in a higher level language anyway. At least be aware of it, right? For low performance engines, fine. Who cares when the garbage collector runs? But it's good to know. Good to know that it will happen and that you have no control over it, and what you don't have control over. So hopefully that helps. Some discussion about what pointers are and how they work. And yeah, I strongly recommend people learn just bare C to get started. It really forces you to understand where your memory went, where it's going to, how long it lives, who owns what. If you have any questions, let me know. I'm happy to explain over anything that you didn't understand, or if there was areas where I glossed over too quick. But there's a lot going on with pointers. Okay, well, where was I? Yeah, so hopefully that helps. Where were we? Journal. I want those. Okay, the books. The books have to be rendered at the same time as the bookshelf, which we kind of started doing. Actually, are they showing? That's a good question. I wasn't paying attention. Play. They're not showing. Why are they not showing? We did not lay out the books. That's why. It's not the Sandbox. The one in one in Sandbox. The books. The books. Books set. There we are. Okay, so here's the actual not layout. We're gonna get our image. We get our book set. We're gonna set the texture. We're gonna compute the book value. We don't care about that or that or that. That's it. And down here, what we don't care about we do need the UV key still. Okay. blah, 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 blah. Yeah, I think that one works. Positioning, and then in the render, we are rendering book sets. So the colors that interact with the brown shelf are not very visible. Yes, that is correct. We are slowly changing out from the crappy programmer art to the mediocre programmer art. So we've not fully contrasted everything yet. There are like, here, let me get this up and running. Yeah, let me just see if I can. There we go. Get this up and running here. Oh, for heaven's sake. Oh, block it. Okay, I didn't know about that. So, block extrude? Really? We need that? Oh, we can put it in. All right, so undo layout. We need to do some refactoring later, but let's just get it up on the screen. Okay, so hey, all the books are on the shelf. Great. So if we go to Sandbox, you'll see that these letters that interact with the box are on letter tiles. So those should be much more visible once we get that all ported over. So the Sandbox, I've just been slapping things on the screen just to get the layout and see how the colors look. Like all of this is going to be given final art, but I think that the contrast there seems reasonable. So we're working towards that. We're moving these assets into the actual game slowly. But yeah, you're right. These, without that tile, they look really bad. And they don't line up because the bookshelf is a different size than the old one. Like this actually looks really bad, but that's all part of the plan. It's all part of the plan. Okay. Those books lay out okay. So, oh my gosh, it's 4:15. I haven't had a snack. Shame. I'm getting tired of chewing gum. So let's see. Let's pause there for a second. Do a little bit of alignment here. Let's pause here for a second while I go do a snack run. I've still got jalapeno poppers. I can't believe my kids haven't eaten them all yet. So, we'll do a snack run. We'll come back and we'll make the books behave properly and then delete the old books from the scene and from the art library. We love removing old crappy art. So, back very soon. Just a moment. Okay. Get a peanut butter sandwich. No, it's jalapeno poppers. Jalapeno poppers are wonderful, delicious, delightful. Okay. All right. So we got everything to show up. So one thing we want to do is set the level in GameScene books material. There, that's the number. Guess count. We want to be able to say set level that the bookshelf or set number of guesses. Okay. Then we want to put this in. All right, so from 0 to 20 minus the number of guesses. Maybe we're upside down. We'll have to take a look. Guesses. Enabled equals false. Actually, x less than. You know, think this through, or just take a while to stab and see which direction we're in. I wonder if one can make a program where the GUI only loads when the cursor gets near a GUI object. I will try it with WX widgets. Yes, you 100% can. I do not know WX widgets, but I've used Qt and I've done dynamic GUI layouts before. It wasn't due to mouse proximity, but there were other conditions that would trigger elements to be added or removed from the UI. Yeah, it is doable. Okay. So we have 20 guesses. Index less than 20 minus number of guesses. 18. The first two will be disabled. Let me think about this. If word index. What is a nice clean way to do this? 1 through 10. We only have 10 book sets. If our index, oh no, we have 10 book sets. If our index is less than, do enable. Now let's just see what happens. I think that's close. So in GameScene, anytime we get m_guess count, nope. Let's see, next level. Somewhere in here. Guess count. Okay. Guess count equals 1, 2, 3 locations where it matters. Bookshelf. Set number of guesses. _guess count. And the same thing happens down. All right. We should be able to see which books show up. Okay. Oh, there's the top row of books. 16. Uh-oh. Oh, 16. Not 20. There's 2 rows. 14. 12. 10. Okay, so the other thing we could test is cheating. So we can cheat. And then that. There it is. It got set. Perfect. Okay. So what this means in GameScene, books material goes away. Okay. Then images, we can remove books. There we go. Get status. Okay. At this point, we should probably Embed our PNGs again. This will start reducing our compile times a little bit. We should really remove coin and test coin. Except right now those are our only tests of the sprite usage. And GBZ can go away. Let's get rid of this one. I think one place GBZ was being used was here. We can just go with ping. Okay. Okay. Re-embed everything real quick. Okay. Image warehouse will take a little bit. Just recently changed. Oh, good heavens. Okay, let's make sure it's still working. Oh, uh-oh. What image are we asking for that isn't there? Line 8. It's only 108 megabytes, really, of text. Not too big of a deal. Line 8. Huh. I do wish an assert would write out a stack trace if you're in debug mode. As far as I can tell, the only way to really test this is if image warehouse get data of something. Get key of our asset. Oh, I wonder. Let's do this. Save. Let's do a clean. Let's rebuild from scratch. That is often the problem when we change a memory footprint. There is no way a value in that enumeration should ever be out of bounds. And these are really good jalapeno peppers. Mm-hmm. Okay, that should magically work. Mm-hmm. Okay. There it is. All right, cool. Nothing's broken. We're going to take that as a win. Group the books onto the bookshelf. The bookshelf displays the books correctly, and we can set the books to show hide depending on the number of guesses remaining. Number of guesses allowed. Okay. Nice. Also a minor cleanup of the old crappy programmer art to start reducing clutter. Add everything. Books on bookshelf. Work. Started removing unused image assets. Cool. I thought that would take me longer, but that really wasn't that bad. Boom. So there's an awful lot of animation work to be done. Where are we at? 4? We're almost at 5. Scene transitions. Notebooks. I would like to get rid of those stupid notebook numbers and letters we've got. I need to know if a notebook has been clicked. What is the best way to do that? Maybe have the shelves full of books with every word correctly guessed, the books decrease. Oh yeah. Um, yeah, we kind of do it the opposite way, where you have 20 guesses when you start, but by the time you're done, you're limited to 10 guesses, which is kind of the bottom limit for reasonable expectation of solving the word. There's also practice mode where you can just start at 10, but you only get one word, and there's no like high scores for it. More for just practicing without having to go through all the lower counts. Full of books, yep. Yeah. Because you kind of want the difficulty to increase as the run goes. Okay. Notebook clicking. How are we going to do notebook clicking? I don't have a good plan. Clicking on notebooks. This is actually coming together reasonably well. This is not bad. Okay, so clicking on a notebook. Because first and foremost, I want to get rid of these numbers and letters, which is what we're currently using to select things. And we have been for a very long time. I want to get rid of those today. So, notebook clicking. What values do I have? Shelf, word, chalkboard, table, notebook, width, height, front, width. Notebook spacing, ISO X. Notebook spacing X, notebook front. So I get the notebook front width and front height, and that gives me this rectangle here. From this corner to this corner to that corner to that corner. We could get that. Then all we need is the notebook ISO width. So basically the distance from here to this edge on the x-axis, and from here to this edge on the y-axis. If we knew that, we can construct these 1, 2, 3, 4 points. And that's 2 triangle test. If we know this point, this point, this point, this point, we can construct another 2 triangle test. I think that's the right way to do it. I think that'll give us a tight and reasonably accurate click detection. All right, so we gotta get some more data out of our old friend. Okay, so there are options here. Notebook might get a little bit more complicated. I would like to do an animation with a notebook. That might be easier to run if the notebook was a separate object. And detecting which notebook you're clicking on might be a little easier. Do I want to separate the notebooks into their own class? It probably would declutter things a bit. Okay, well, let's go to our tools, our layout math script, notebook width, height, front width. We want the front height, which is equal to the cover width twice over plus the page height. Okay. Then the isometric width, isometric height. Oh, we have to change that. Everything that was scaleW becomes just scale. Everything that was scale height becomes scale. That was a refactor we did. Okay, so this is ISO width self dot cover height. ISO W, ISO H. I think that's what I want. Okay. I kind of want to break notebooks out into their own thing now. I think they'll get complicated enough. Okay. Let's go to tools. Let's run our layout math.py. We're going to use the old notebook. I'm going to put that out into temp.py. Normally I would, we can show it, why not? Let's bring up Inkscape, share the whole screen. Let's see that. Where's my Inkscape? It should be coming up soon. See, this is what I mean. Why? Why is Inkscape taking so long to start up? Well, why? Just to show that. Good heavens. How disappointing. Modern software could be awesome. We have so much compute power. Why does it take so long to do anything? And I'll tell you why. Because a lot of this junk is written in Python or just terrible. As we load up a Python script to do some math for us, let's see if this outputs everything I need. there are some numbers. That's basically all we needed. Back to Emacs, my favorite. GameScene. Well, the numbers look the same otherwise. Notebook ISO. Oh, that is not the width and height we want. The height is 2 times the thickness plus the page thickness. So let's take a look at it. Oops, here we are. Page height 24 plus the cover height of 16 is 40 pixels. That is not 40 pixels. Page height, cover height. Cover height. Pixels. There we go. That's one thing. And then we want the page or the cover depth. That's the ISO we want. ISO with self dot cover height. I think. All right, back to sure, we can do it again. All right, so we're gonna hit OK. So that's our book as generated by a script. So we can delete that. Roll vector art, and then run the script again. And now the what? Those didn't change, nor did that. That's unfortunate. Did we not save our script? Oh, we didn't run our script. There we go. All right, apply. These don't look any different. Well, shoot. Tools temp to apply. Hmm. Notebook. There's the front height, 40 we expect. That is not. Yeah, so width and height we expect. Cover height. Cover depth. That's a problem. Okay. All right. Now we run our new script. There's 40, and that looks better. Those are better isometric angles. That's all we needed. Therefore, So we're saying we want notebook in its own class. I think we do. Okay. Because we want to detect clicks, and doing that here is not the best. So bring it out, bring it its own thing. It makes sense to me. Okay. Okay. Only texture quad. The image warehouse. Want event queue and mouse press event. I think those are the ones we're most interested in. Each notebook has sections. Each section has a number on it. That is kind of the purpose of the for notebook. So let me just see if I'm in a working state. Let me show you what I'm talking about. So if I'm playing along, let's see here. Yes, I know the word song lined up. Prime Lunch Toads, Ultra Demon, Place Rhino, lines. Hopefully this one doesn't give up all of its secrets too quickly. It might. Shoot. Okay. But one thing we can do is, and this is a little hard to see right now because we're still dealing with the old thing, is we can copy this deduction space into another one, into a different notebook. So the C is copy from the currently active notebook into the current notebook. So the C, we're now in notebook 2. And we can copy that to 3 and 4. So what then I can do is I can look at 2, and I can say, hypothetically, without changing any of the other 4 deduction spaces, what if J and K are out and Y is in, right? Maybe it's something. Doesn't matter. But then over here in workspace 3, in notebook 3, we can assume that, B is in and not F and G. So we can basically do speculative logic using the 4 notebooks to copy from each other into each other, or to do individual deductions within a single notebook space. So that's what the 4 notebooks are for. There's a very common pattern I end up with where there are 3 available letters in a word, but only 2 of them. So let's see if we can clear out workspace 3. So for example, if Rhino had 2 letters out, one thing I will often do is I'll copy that to all 4 workspaces from wherever I was deducing, and I'll go to 2 and I'll say, what if R and N are in and O is out. Then I can check for logical discrepancies. And in 3, I might go R and O are in and N is out, and not R, O, N. So now I have 3 combinations that I can compare and look for deduction contradictions within each one. So if 3 has a contradiction, like R proud has only 1 match, but it's got 2 letters, I know this one's out. Workspace 3 can't work. So it just goes away. And now I'm left with 2 and 4. You can look for those logical deduction contradictions. So like demon would do that. Nope, now prime is invalid. So 2 can't be it, so we can clear this one. We're left with notebook 4. We can continue down that logical line. So you are intuitively exactly getting what the point of those notebooks is. Adobe Illustrator requires 8 gigabytes minimum. Yes. Yes, and if you look at Adobe Illustrator from back in like the 90s, your load time is similar, if not worse. Why? It added almost no significantly new features. Nothing that would warrant the kinds of performance times that increase given the amount of hardware available. The same thing has happened with IDEs, right? Why does it take so long for Visual Studio, Microsoft Visual Studio to open? Why? What's it doing? It's still working in plain old text. Why is it so hard? Bloat, poor understanding of abstractions. Applying abstractions without thought or measurement. Shoot, I'm out of hot water. It's okay. We'll just chew down for a while. Okay. Anyways, back to notebook. Let's steal some things out of button. I know this accepts mouse clicks. But the thing to handle a click. I'm just going to handle a mouse press. Okay. Okay, we're not going to do anything with it right now. Maybe these companies appreciate a dev who codes a lot, not a dev who codes efficiently. Yes. Well, it's a little bit more complicated than that, but yes. What you measure is what you get more of. So I know that in a lot of companies, what they'll look at is the number of tickets closed, like job tickets or tasks, or they'll look at your commit history. How many lines of code did you commit? Like just a volume. So what do you get? Either a lot of commits or very big commits that don't do much. There's a story from way back in the day, Microsoft, when they were working on Excel, there was so many bugs, and they decided they were going to reduce the bug count by incentivizing the developers that they were rated based on the number of bugs closed. right? So the developers started doing some funny things. Like there would be a ticket come in that says, you, this text that I selected should return 12, and when I request the font size for the text that's selected, it's not 12. So what would the dev do? He'd go into the function that returns the font size and hard code return 12. Boom, ticket done. It passes the test, submit, commit, done. Knowing that in about 3 minutes, the tester's going to come back and say, oh, when I select this text that's size 16, it does not report 16, it reports 12. And then you go fix that one, right? What you measure is what you get more of. Or there was another one way back in the day, way back in the old Mac days. Let me see. Do I have a link to that? I have a link to that stored somewhere. Let me check real quick. La 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 la. Here it is. This story. Fun little read. Actually, this whole thing is kind of a fun little read. Just put it in the chat. But basically, there was this hotshot programmer working in the early days of Mac, and the company was getting more and more corporate. And one of the things that came down was at the end of each day, you had to fill out a slip of paper with your name and how many lines of code you wrote that day. And this hotshot programmer who actually knew the system, like he was actually good. Like a lot of the reason we have modern computing in the state it is because of people like him. He was refactoring a whole bunch of assembly code, right? Tons of it. And he, made some little subroutines and deleted this code. And at the end of the day, he sat down with this stupid little note card. He's like, my name is this. Lines of code today, -2,000, and turned it in. I guess that practice didn't last long, but yeah, what you measure is what you get more of. It's why I don't believe in certificates or that sort of thing. Because once you, like in the early days, the CCNA, the Cisco certifications were worthwhile. It meant that you did work, you read the book, you took the test, you did it hands-on, and it meant something. But then it became a game of, do you have the paper? Not, do you know how to use a Cisco router? Do you understand networking protocols? And so it's become instead a game of, what's the cheapest, easiest, fastest way I can get to barely pass the test at all? And that's what you get. You get people with pieces of paper, because that's what you're measuring. And that happens everywhere. Like there was a farmer I knew, he was looking to hire a welder, and he put out a job rec. A whole bunch of people applied. He picked like the best 6, and brought them into their shop, and he said, all right, here's some tasks. Weld this to that, weld this to that, weld this to that. And like 4 or 5 of them were like, what? Well, we have a doctorate in welding. And guess what? They couldn't lay a decent bead of welding. The guy that got it, uneducated high school dropout, but the guy could weld. Like he knew how to do it. So, yep. What you measure is what you get. That's one problem. The other problem is that these big companies are being managed by people who don't understand software at a deep level. So when somebody says, oh, hey, there's this new framework that comes along, and it'll save us all this time. 1, you never measured how much time it's going to save you. 2, nobody measured how much time it was going to have an impact on the runtime, right? So the performance implications are never done. Caught MBA. I didn't say it out loud. Yes, you're correct. Cough MBA. Yeah. But for some reason, them in college, they all got issued laptops, while the computer science guys just had to go to the lab like everybody else. Oh, what a world. Yep. So yeah, there are so many things wrong with the way that modern companies are run at scale that are just bad. Okay, where was I? Mini rant over. Unless somebody has a line they want me to take on that, but I think that mostly addresses it. I need to know a thing. GameScene. Okay. Oh, that was the one I wanted. Set the texture. Get the UV key. Oh, cute. Wait. Hmm. Hmm. Okay. Already we have to start doing things a little bit differently. Set book index. Which does remind me, was there a thing on bookshelf dot? We need to assert the number of guesses greater than or equal to 10. We need to assert the number of guesses is less than or equal to 20. We need to assert that the number of guesses is an even number. Okay, here. We're going to set the book index. Okay. Assert index is greater than or equal to 0. Assert that index is less than 4. We only need 4 notebooks. I think that's it. Given our index, we can compute the UV key and done. Yeah, Curdo, I have a relative who teaches Internet of Things at a college, and he really could not code in any programming language. I really think they waste a lot of time in universities. In Iraq, 10,000 is a year's salary. Some universities charge that much without teaching code that much. My friend is an American university in his 4th year and still doesn't know OOP. Yeah. So I would argue that my college experience wasn't that great. I had a couple of really good teachers that I really liked, and then I had a whole bunch of teachers that I really didn't like. And the main difference was the ones I liked had actually gone out and worked in the industry and knew programming. And the ones that I did not like were the kind that went straight from their bachelor's, straight to their master's, straight to their doctorate, and frankly, never learned how to code. But even then, like midway through, I finished up my first year, and then they changed the requirements for a computer science degree. And I looked at the new requirements, and they had taken out compilers and put in like software engineering 1 and 2. And I was like, what's software engineering 1 or 2? And it was basically drawing UML diagrams. So I was like, wait, you're taking the hardest project class you can out of the curriculum and putting in drawing boxes and lines. So I insisted to my advisor that I was not going to be updating to the new catalog. I was staying on the old catalog. Because that was the one thing I did, was I made sure I took every project-based class I could. You had to write real code to get through. So yeah, a lot of it has to do with what classes you choose to take as well. You do have some say in your own education. But yeah, it's expensive, and these days I would argue it's worth less and less every day. Okay, we need a render. Like bookcase, bookshelf lid. Texture quad. I'm going to go for texture. Not that I'm thinking that OOP is the end all be all. In fact, in some cases, it's actually terrible, objectively terrible, like measurably terrible. It's just another tool. But you should be familiar with more tools. And the fact that people graduate from college barely knowing a little bit of OOP and like the keywords to say about it, and don't really understand the downsides of it and when you shouldn't use it, and what the alternatives are, like that kind of boggles the mind. It's like you go to carpentry school, but they're like, here's a handsaw. You're like, well, there are other tools, man, like hammers, nails, screws, drills, scroll saw, chop saw, band saw. Like, why are we so focused on this one thing? It's just another tool in the toolbox. Ugh, a little bit maddening. I think that's what I should do. I should start my own. What's it? At least they will learn how to blame cis white males. I got out before that. But yes, that was a thing. Or that is a thing. Woof. Yeah, unbelievable. Absolutely unbelievable. Okay, so we're registering a mouse press handler. We're unsubscribing from it when we're done. This thing should do things. It should return false for now. Notebook clicked. So that's going to print out like 4 times every time we click the mouse. I'm not even studying CS. I like chemistry, so I make programs with C++ that show chemical reactions. Yeah, and the sad part is because you're actually trying to solve real problems, you may become a better programmer than a lot of CS programmers who are over there drawing their little UML diagrams. Like back in the day, I used to make fun of like electrical engineers and mechanical engineers who wrote software because it was always bad. It wasn't good software. But I've also gotten to the point where I've met so many software developers who can't write good software, and I'm like, at least the mechanical engineer and the electrical engineer solved their problem. They didn't solve it well, but they did solve it. Whereas these CS people, oh my gosh, and so far up their rear, they don't know what's going on. Not all of them, but enough. Um, does the notebook need a layout? It kind of doesn't. What am I thinking? You know what? We'll do it. We'll just do a do layout. Actually, we don't really need to. It's only one thing. So if we go to GameScene, where we lay out these notebooks. we need a set rectangle. Do we? Notebook, set rectangle. Zero. Notebook width, notebook height. That is actually most of what we care about here. Notebook spacing. The ISO spacing comes in here. The height. Where did notebook spacing X come in? What does that mean? Who defined that? For some reason, it's 60. I guess that's fine. Spacing ISO X, spacing ISO Y. Okay. So these can be taken straight off the notebook object we get. Set affine rectangle to the same. Then we can move to I went to his house. He was trying to lose weight, so he would measure calories of fruits and nuts on a piece of paper. Made him a calorie calculator that he can use. Yep. Yeah. Well, and that brings you to the three primary attributes of a good programmer. First one is it the first one? That doesn't matter. Laziness. Why am I working so hard? Let the computer do the work. Laziness. So important. I have some convenience functions for containing things. Parent raw rectangle does contain screen point. It only checks the raw rectangle. The inverse of the world transform times my screen X, screen Y. Scale, rotate, yeah. I really only have that one function. Target X, target Y. Okay, so I'll get around to that eventually, but that's much of the same principle applies here, except actually colored quad. Somebody somewhere has a better contains method. Yes, exactly. This kind of thing. C color quad dot contains probably not going to get that far. But if we can just get the notebook rendering the way we want, none of that stuff really matters right now. Let's get the notebook. We get the render done. I think so. Okay. Notebooks. Sure. In theory, all we should have to do is notebook 1, 2 set index set index to index. At which point one asks, why is this multiple lines? Simplify, simplify, simplify. Notebooks. Okay, notebook. We do not need to set rectangle. What we need to do is notebook to move to notebook X, notebook Y. In theory, and if we're only doing one operation, there's no point in us being silly about this. Ooh, two-liner, perfect. I think that's basically it. Let's just try it. Oh, can't try it yet. Bookshelf. Notebook. All right, let's try it. Have a good day, bro. Need to get some sleep. Thank you for amazing explanation. Thanks for coming. Thanks for your questions. You have a wonderful night's sleep, and we'll see you in the chat some other time. Have a good one. Thanks for the interaction. I always appreciate someone to chit chat with. 533. What are the odds we can get mouse click working? In 15 minutes. We can compute 1, 2, 3, 4, 5, 6, 7, 8 points. 8 points defines all of the dimensions of the notebook we can check a click against. This is why I want to break the notebook out. The click detection is involved enough. I didn't want to clutter too much with the other thing. Actually, we needed to do a point in triangle function somewhere. I just don't know where to put it. Global space? I don't really have a math space yet. Do I write a math space that just contains the one point in triangle test? Maybe. Maybe we do. Maybe we do. It's such a handy function. Okay. The about scene is taking way longer than it should. What's going on here? There's not that much about the about scene. What's going on? Is my computer indexing a hard drive or something? This seems really slow. Even for me. Even for GCC. Seriously. Where's all my resources going? Holy smokes. Well, close Inkscape. That's not doing anything. We're done with it. What else is going on here? In that Discord browser. The browser is eating up a good amount of memory, but it's not that much. 37%. I should not be lagging this hard. This is pretty bad. Okay. Oh. It's equal to 0. There we go. Unused variables I don't care about right now. Notebook. That is fair enough. That is fair enough. All right. While we're waiting for things to navigate. I thought I fixed that one. Fixed everything but that one. Okay. All right. Almost there. So if these show up in the right place, good enough. We will use that E here shortly, but not yet. Oh my goodness. Huh. Huh. Oh my gosh. Okay. cpp.hp. I cannot believe we did that. All right. I mean, I can believe it, but oof. A little bit ridiculous. Okay. Oh, what? Um, what's the definition? What? Possibility number one. Those old object files have too much stuff in them because of those pound import CPPs. So maybe this just fixes it. Or we have to think. Is that what was slowing us down before? Is ending up with lots of really bad imports. Things are moving a lot faster this time. So maybe that was the problem. Okay. I think it was. I think that's why the file was taking so long, since we were importing so much CPP into the header. Then every object had a whole lot of definition in it that did not need. Okay. 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 Now to try it out. The notebooks are up here, not down there. Oh. Oh, I better know what. Texture of this. We want to initialize the parent relations correctly. Notebook header. Okay, fine. No, I don't like that. File. What's wrong with notebook.cpp? Okay. All right. Okay, there's my notebooks. They laid out correctly. Good. Oh, oops. I was going to check. If we click on them, what happens to my output? I should get 4. Are you clicked? Good. One more thing I need. Notebook. Int index. All right. All right. So make sure those are working the way they are intended to work. Then we click 0, 1, 2, 3. Perfect. Okay. Brings us to this thing, which is going to start looking a lot like color quad, where we get those. Let's do a search for this in the code. I want to see this in multiple places. Ref-r for this. Exclude dependencies. Color quad and my shader warehouse. Yeah, I knew that the shader warehouse was going to have 2 copies because of clipping testing. Okay, so color quad's really the only place right now. So this should be easy to move out. Math, I guess. Okay. Namespace. This point in triangle. All right. Double X, double Y, double X naught, double X1, double Y naught. X1, double Y1, double X2, double Y2. Let's see math in here. This basically maps to whatever was in color quad here. Okay, so what we're doing is we're taking this point here. We're drawing a vector to this point. And then we do a dot product to see if it's positive or negative. And then we do the same thing to here, positive or negative, and here, positive or negative. If we go around this triangle in the same direction, if we go around the triangle either direction, it doesn't matter. But all of them have to be positive or all of them have to be negative. That's really it. So this checks a secondary triangle if needed. There. So, in theory, in color plot, you can now replace all of this with the following. Oops. Color quad, CPP, color quad. Oh. Return math is point in triangle, or math is point in triangle. That's basically it. X, Y, bunch of numbers, X, Y. So here, these are the corners. X0 underscore X1 underscore X1 underscore Y1 underscore X2 and underscore Y2. Otherwise, we try this one, which is 2, 3, 0. Two, 3, 0. There. That should just work. Now, do I actually have any color quad contains checks anywhere? Kind of doesn't matter. We'll just check against the other thing. So let's make this compile. So where's like ease? Probably most near to that. Oops. Failed that one too soon. Okay. Whoa. Okay, guess it doesn't need that, which is one of the things I hate about C++, consistent syntax. Yes, thank you. Oh. Zero, 1, 2, 0. All right, as soon as this finishes, we just do a quick rebuild and make sure it still builds. Oh, no, no book. Oh, okay. I'm not sure who else is calling that then. Mouse press event has X and Y. E.X, E.Y. Oh, hey, thanks for the follow. Always appreciate a new follow. Stow4KE, nice. Welcome aboard. Let me know if you have any questions. Otherwise, I basically do programming with stream of consciousness as a talk through what I'm working on. What we're doing right now is this notebook has a funky shape. And so to detect if we clicked it properly, we're gonna have to do a bit of magic to properly detect. And then use variable. That I can live with. So let me just, oops. So if we go in here, the rectangle that actually defines this notebook is basically this corner over to here, then down, then over to here, then up. So detecting that we're clicking it would include a lot of like table space, and there's this overlap here where these two might overlap. So what we need to do is check this front rectangle, which isn't hard, but then we also have to check this weird parallelogram and this weird parallelogram. So to do that, we're going to use this math function, which checks to see if this point is inside this triangle by doing dot products and making sure that the signs are all the same. If all three point out, if they're all negative, then it's inside the triangle. If they all three point in, then we're inside the triangle. Otherwise, if some are in and some are out, it means that we're outside the triangle somewhere. So 3 dot products and you're done. That's basically why that's such a good algorithm. JTL, thank you. You have a wonderful evening as well. So that ran and it didn't die. So that's good. I don't think we're doing any color quad contains anywhere. Not right now, anyways. Okay, let's see. What do we got? Whoa, okay. Button contains kind of doesn't count. Color quad game scene. The letters contain. That's a different question. Int spinbox contains. Notebook rectangle. I don't think rectangle uses this method. Yeah, it's just balance checking. Shader warehouse, we're ignoring that. Text, I think, does the same rectangular check. So yeah, the only one that has it implemented right now is color quad, and nobody uses it. So notebook. All right, double. Hmm. We can compute 8 points, or we can store 1 point and store 1, 2, 3, 4, numbers. Except we don't have to. We can literally just use the 4 numbers. So what we need are double front face width, front face height, ISO width, ISO height. Which is basically this. ISO width, ISO height. Okay. Now, so this is going to take the world transform. So anything that we did to position the thing, this undoes it. This basically applies the same transforms to the mouse. So it puts the mouse from screen space into our local space. Now, we'll be able to do we want the rectangle from we don't need a whole rectangle, do we? Basically checking the front face is a rectangular check, which is easier than dot products even. So we'll start there. And the front face is going to be at you know what? Let's go to math. Let's go to where is it? Rectangle contains. And put that into math. Double X, double Y, double X naught, double Y naught, double width, double height. This is useful enough. We might use it outside the context of a rectangle. So a rectangle with X naught. 1, 2. Y will become Y naught. And W and H. That's basically it. Therefore, X, Y, this X, this Y, this width, this height. Okay. That one we can check. Okay. Because the button won't work. Everything uses the rectangle check. Nope, that one. Actually, let's go check text. Which is in here. We invert the coordinates. Raw rectangle contains, which is fine. Okay. Because that calls the math. Okay. Settings, play, yeah. So the buttons all register position correctly. Good. Which brings us back to the notebook. This rectangle Yes, it's M underscore text, just in case. Okay, so we get the rectangle. The raw rectangle. They should be the same. Ultimately. Okay. Then we can check our front panel. Is our notebook height, so r dot height minus ISO height. So if I remember right, these are the lowest, most. Oh, it's after 6. I've got to get going. All right. We'll construct all the points of interest. There should be 8 of them. It's not, why not? Oh, no. This one here and r dot x. R dot y. Plus height minus our ISO. But this is inverse the world transform. So this can all be done relative to 0, 0. How much for text? Dot raw rectangle. it's the raw rectangle. Okay. X, Y. Which is the Y plus the height minus the, what do we call it? We can just subtract the ISO. All right, x1 equals, we'll move down. Which is r dot y minus, or plus, r dot height. Two and three. This is r dot x, which is x sub 0 plus the front face width. Zero equal to y1. So this is the bottom left edge. This is the bottom right edge. Actually, we don't need these points. Like this one, we don't actually need. Okay. X0, X1, X2, X3. Maybe that's a better way to do it. So X0 equals r dot x. X1 is r dot x plus ISO width. X2 equals front face width plus r dot width. Those are the x coordinates. That feels less terrible. Okay. So y0. We'll go from the bottom edge, I guess. R dot y plus r dot height. We'll go up. So y0, which is, we want to move from the bottom up. So it's y0 minus underscore front face height. Y2 oh, interesting, is y1, we move up underscore one more. Oh, it's y0 minus the iso height, isometric height, then y3 it's just r dot y. Okay, so first we check. Map is point in rectangle, x, y, and here we want x nope, x0, y is 0, no, y1, underscore front face width, underscore front face width height. Okay, let's just see if that works. If I've made any sort of sense at all, this shouldn't be too bad. Oh. This is true. Click. All right, I just want to see if we can get this one hit, and then we're done. We can't go too late. Hopefully we didn't overthink it too much. So we're just looking at the output on the console. Notebook 0, 1, 2, 3. Now the top face we're not catching yet, and this side face we're not catching yet. But the front face we are. Cool. All right, we're done there. Let's up that in our journal real quick. Started implementing clicks in notebooks. Only the front face responds currently. Refactored some contains code into a math namespace for better reusability. Math has contains functions. Notebooks can click front face. All right, I think that's it. We're gonna call it there. Thanks for jumping in. Come join us tomorrow, same time. We do game development Monday, Wednesday, Thursday, Monday, Tuesday, Wednesday, Thursday, and then Friday we do compilers. So feel free to join us, ask questions, or just stop and listen while I stream of consciousness and code. Have a wonderful evening. See you tomorrow. Bye-bye.